Hello friends, welcome back to my classroom. In this class, I'll try to explain how to multiply two matrices, which will be very helpful in identifying regular stochastic matrix and also in finding higher transition probabilities. So before understanding how to multiply two matrices, let's understand what is the order of a matrix. Let me take an example. Suppose a matrix A is there with certain number of rows. Say it has two rows and it has say 3 columns. Then the order of this matrix is said to be 2 cross 3 because it has 2 rows and 3 columns. Okay, and whatever may be the elements inside, there will be 2 into 3, 6 elements will be there. Say 5, 6, 2, 0, -4, 1. Right. So in other words, like suppose A is of order m cross n, that means that there are m rows and n columns in the matrix A, right? And this 5 is the element A11 because it's sitting in the first row and first column. In other words, Aij is the element which is in the ith row and jth column. Say for and one more example, if you consider this one is sitting in the second row and third column. So this element is A23. All right. So now, suppose now you want to multiply two matrices. It has to satisfy a condition of order. Suppose A is of order m cross n and B is of order p cross q. Then the multiplication A into B is possible. A into B is also written as AB, and this multiplication is possible only if the number of columns in the first matrix is equal to the number of rows in the second matrix. So I'll give you an example where matrix multiplication is possible and also where it is not possible. Suppose A is a matrix of 3 by 2 and B is a matrix of order 2 by 7, whatever it is, the number of columns. Rows should match. Alright. This matrix multiplication is possible because the number of columns in matrix A and number of rows in matrix B both are equal to 2. And if I take one more example, A is of order 3 by 2 and B is of order 4 by 3, then this matrix multiplication is not possible because 2 is not equal to 4. Right. Let's understand how exactly the multiplication is done with a couple of examples. Suppose I take a matrix A. I'll take a smaller numbers so that our calculation will be easy. If you have big numbers, you can make use of your calculator for computation. Alright. Suppose A is having the element 1, 2, 3 and 0, 1 and 4. And B is, and definitely B should have three rows because A has 3 columns. This is a 2 by 3 matrix. 3 columns are there. And B should have 3 rows, then only the matrix multiplication is possible. Say I have 1, 4, 3, 0, 2, 1, 5, 0 and 2. Alright. So if these two are the matrices to be multiplied and this is 3 cross 3, so definitely the resultant matrix will have 2 rows and 3 columns. So how to calculate the elements of the resultant matrix? Now AB, suppose A into B is equal to C, the matrix C. This is the resultant matrix. So the elements of this resultant matrix is found by the sum product of the ith row and jth column in the matrix A and B respectively. That means the first element of the resultant matrix C, which is sitting in the first row and first column, that means C11. C11, if you want to find the element C11, you need to choose first row because C11 means first row and first column. First row in matrix A and first column in matrix B, not the row. So first row in matrix A and first column in matrix B, and their sum product is found. How to find the sum product? It's very simple. First, I'll take the product of, I'll take the different one. Yeah. First, I have selected the first row and first column. I don't look at second row of matrix A and other columns of matrix B. Only the first row of matrix A and only the first column of matrix B. In that, we take the first element and it will be multiplied to first element of the first column. All right, that means 1 into 1 in this example. Then I'm going to add this to the next element in the matrix A and the next element in the matrix B. So second element with the second element. All right, 2 cross 0, and similarly plus the last one now. Last one is 3 in the matrix A and last one is 5 in the matrix B. So in the matrix A we go from left to right, and in matrix B we go from top to bottom. 3 multiplied by 5, and you can compute this, all right, and get the result. All right, I'll write the result also. What is the sum product? 1 into 1 is 1, plus 2 into 0 is 0, plus 3 into 5 is 15. So 15 plus 1 is 16. All right, and now I have done with first row and first column. Now I'll do with first row, but I'll change the column. First row in matrix A and second column in the matrix B. Instead of first column in matrix B, I'll take the second column in the matrix B, and similar calculation is done. All right, so instead of this, we had 1 and 4 there, so I'll choose the second column now. So second column has 4, 2 and 0. So 1 is multiplied to 4, plus 2 is multiplied to 2, plus 3 is multiplied to 0. So 2 2s are 4, plus 4, 8 plus 0, which will be 8. And similarly, now with the first row of matrix A, I'll take the third row of matrix B. So this will be 1 into first element, 1 into 3. First element is 1 into 3, plus second element is 2 is to be multiplied with 1, 2 into 1, and the third element is 3 to be multiplied to 2. 3 to be multiplied to 2. This will be 3 1s are 3, plus 2, plus 3 2s are 6. 6 plus 2 is 8, 8 plus 3 is 11. So first row is completed with all the columns of B. Once this is done, I'll go to the second row of matrix A. So now I'll strike out matrix A. There is no use of first row in the matrix A now. Hereafter, we will do the calculation with the second row of matrix A. And now this has to be done with every column of matrix B. All right, sum product of the second row of matrix A with all the columns of matrix B one by one. Right. So first one is 0 is to be multiplied to 1 when I choose the first column of B. 0 multiplied by 1 plus second element is 1 multiplied to 0 plus 4 multiplied to 5. Right. So 5 4s are 20. That's it, because 0 plus 0 is 0 plus 20 is 20. And now this is second row, second row with second column. Second row of matrix A and with second column of matrix B. So 0 into 4, you can look at the values carefully. 0 is the first element of second row in matrix A, and 4 is the first element of second column in matrix B. 0 into 4 plus 0 into 2, sorry, not 0 into 2, it will be 1 into 2. The second element is 1. 1 into 2 plus 4 into 0. So this will be 2 into 1 plus 0 plus 0. So this is going to be 2. And now the second row with last column. Second row 0 multiplied by 3 plus 1 multiplied by 1 plus 4 multiplied by 2. 4 2s are 8 plus 1, 9. Right? So this is how we multiply two matrices. And I'll take one more example where I'll have only one row. I'll take a row matrix as the first matrix because this will be useful in finding the fixed probability vector and also uh, finding higher transition probabilities. So let me take matrix A as having only one row, say 1, 2, 3, and matrix B with 3 rows because 3 columns are there in matrix A. 3 rows, 4, 3, 2, 0, 1, 5. Right. So let me stop it. Okay, only 2 columns I'll take. So this resultant matrix C, I'll choose only one row is there in A, so only the first row. But columns we have two. First I'll choose first column. So first row I have chosen in A, first column I have chosen in B. This sum product will be the element of first row, first column in C. That means this position. Right. So what is it? 1 into first element is 1, first element in the matrix B is 4, second element is 2, so plus 2 multiplied by second element is 3 here, plus third element is 3 multiplied by third element is 2 here. Right. So we got the value of first row and first column. Now I'll go to first row in matrix A, but I'll go to second column in matrix B. So how it's computed? First element is 1 multiplied to first element 0 plus second element is 2 multiplied to second element in second column plus third element I have taken from matrix A and third element I am taking from matrix B. So since only one row is there in matrix A, C will also have only one row. And this computation you can do. 4 into 1 is 4, 2 into 3 is 6, 3 into 2 is 6. So 6 plus 4 is 16. And here 1 into 0 plus 2 into 1 plus 3 into 5. So 15 plus 2 plus 0 is 17. And did I miss anything? No, two columns are there in matrix B. So C will have only 2 columns. Okay. So hope you have understood how to multiply two matrices, and you can make use of this in understanding regular stochastic matrix and also use it in finding higher transition probabilities. Thank you.